So welcome to Academic Digest class. Today we are treating complex numbers. We started with addition and subtraction of complex numbers. We know that complex numbers are a set of numbers with real and imaginary parts. So set of numbers with real, that is a plus bi, and imaginary parts, and I is equals to negative root -1. So in complex number, we say that naturally we don't have numbers, like we can't take the square root of any number and get a value that is negative, so we call it imaginary. For example, square root of -2 is the same thing as saying root 2 times root -1, which is the same thing as saying root 2i. Understand? So if I know that this is not the video for explanation of complex numbers, so this is for calculation. We've already done the explanation of everything complex number on the first video, so check that one out. So they said if z equals to 2 plus 5i and w is equals to 4 plus 3i, they say we should add up and subtract. So to add up, I'll just say add the imaginary parts. So this is 8i, this is 6, so plus. So z plus w is equals to this. Now to get the zw, to subtract it, I'll do 2 plus 5i, then 4 plus 3i. So the principle for subtract, the principle is simply add the imaginary part, add the real part. So to subtract, 2 minus 4 is -2. Then 5 minus 3 is 2, so 2i. So for z minus w, this is our answer. So with that said, they give us another one. They said 9, simplify and write. So for 9, I have, let's say I have that, they say in the form of a plus bi, that is this question now. So to do this, let's say I call it a to be equals to 9 plus I, then the b to be equals to 2 minus 3i. Then they said I should add it up. So if I want to add this up, then I'll simply say 9 plus 2 is 11. I plus minus 3i is the same thing as saying minus 2i. So a plus b is going to be equals to this. Now if I want to subtract, I'll say a, b. Let's do it the same. So this is how I like doing my own. You can choose to write your own out. I like doing my own like this. So minus, the minus will simply be the real part minus the real part. So 9 minus 2 is going to be 7. Then I minus 3i is going to be plus 4i. So a minus b is equals to this. So, and it's in the form a plus bi. So once I know this, I want you to now solve these ones for me. Solve the remaining ones for me. So solve these ones for me. Let's move to multiplication of complex numbers. So for multiplication of complex numbers, multiplication is additive and is also distributive. Is also associative. So I don't have to be doing real parts and imaginary parts. So for example, if I see, let's say I'm giving z equals to 2 plus 5i, and then I'm giving w equals to 4 plus 3i. In order to do this, the principle will simply be z dot w, that is z times w, will simply be the same thing as saying 2 plus 5i, just like I multiply polynomials in algebra, 4 plus 3i. So this is the same thing as saying put 2 here, do these 2 to multiply the second bracket, then plus 5i into 4 plus 3i. So this is going 2 times 4 is 8 plus 6i plus 5 times 5 times 4 is 20i plus 15i squared. But we know that I is equals to root minus 1. So I squared is going to be root minus 1 all squared. This will cancel this. So I squared is the same thing as saying minus 1. You need to always note this. So if I know that, that means that this is set as in 15 times minus 1. So plus 20i plus 6i plus 8. So if you do the maths very well, you get that this is minus 15, then 20i plus 6i plus 8. So by the time you sum up collecting 9 times, this becomes automatically 6 plus 20 becomes 26i, then 8 minus 15. So 8 minus 15 is going to be, if I remove yes, if I remove 8 plus, sorry, 7 plus, okay, this is going to be 7, because 7 plus 8 is 50, so it's going to be minus 7 plus 26i. So I can choose to leave my answer in this form, or I can choose to say minus 7 minus 26i. Whichever way I want to leave it, so but this is my final answer. Alright. So that's for the multiplication. So they gave me this, they said if I have something of this nature, I'm solving E part, this E part, you solve the rest for me. So let's solve this E part. So I have minus 2 minus 4i all over I. Alright, first of all, just like your sword, that is the E part, just like your sword, it is wrong for I to be at the denominator. So I'll use I to multiply both the numerator and the denominator. We'll call it conjugate. So this is going to be the same thing as saying, first of all, this should be minus, so this is going to be the same thing as saying, do it this way, I times minus 2 over minus 2i, then I times minus 4. Because first of all, if I do, let's do it this way, if I do I into minus 2 minus 4i, hope you know that's what it means, because I don't want to leave that bracket outside. So this is going to be minus 2i minus 4i squared all over I times I. This is the same thing as saying, let's do it this way, it's going to be I squared. So this is going to be the same thing as saying minus 2i, then minus 4 into I squared is minus 1 all over I squared is minus 1. I just showed you how to do that. So minus times minus becomes, this becomes minus 2i plus 4 all over minus 1. And this is going to be the same thing as saying, this cancel this and this. This is going to be the same thing as saying minus 2i over minus 1 plus 4 over minus 1. So putting it in the form a plus bi, we are going to have that this is going to be the same thing as saying minus 4, then plus, because this will cancel this, plus 2i. This becomes my final answer. Yes. So the next one we have to do is equality of sets. So we've done addition of complex numbers, we've done multiplication of complex numbers. So you solve the remaining ones for me as your classwork using the same person. So for this one, you said given 3a plus 7bi equals to 9 plus 14i, for what value of a and b is 3a plus 7bi and 9 plus 14i equal? So what I will simply do is to write what I'm giving out. So for what value of a and b are there equal? So they give me 3a plus 7bi is equals to 9 plus 14i. So first of all, for sets, for complex numbers rather to be equal, the real part must be equal to the imaginary part, and the real part must be equal to the real part, and the imaginary part must be equal to the imaginary part. So I'll simply say 3a is equals to 9. That's by comparing. You can see by comparing real and the imaginary part. So by comparing, 3a equals to 9. So which means divide both sides by this to get a. So this will cancel this. So this becomes a equals to 3. Also, Also 7bi is equals to 14i. Yeah? So making this subject of formula, I have I here, the two can cancel. So making b subject of formula, I have 7b is equals to 14. So divide both sides by 7. 7 will cancel this. 7 here 1, 7 here 2. So b is equals to 2. Are you seeing it? So which means that the values of A equals to 3 and B equals to 2 are the values of which this left hand side will be equal to the right hand side. So at A equals to 3 and B equals to 2. So that's your answer. So let's move to the next question. So the next one is conjugate of a complex number. So we say that complex numbers are conjugates when we know that, for example, the signs can change. So right here they give me 3 plus 7i. So 3 plus 7i, what is the conjugate? 3 plus 7i, the conjugate is simply, I will represent conjugate with, if this is the complex number, sorry, z is the complex number, we represent the conjugate with z prime or z hyphen or z conjugate, something written like this. So it's simply going to be 3 minus 7i. Just change the sign. So they give me another one, 5 minus I all square. What is the conjugate? The conjugate is simply 5 plus I square. Yes, you can even solve further first, or you can choose to say this is the sentence saying, let's be sure. This is the sentence saying 5 minus I into 5 plus I. Let's check something. 5 times 5, 25. 5 times this plus 5i, then minus 5i, yes, then this is I, so minus I square, yes, so that this and this will cancel, so that you are now left with 25 minus I square, yes. And if you check it, since this is current square, you can see that this is sentence saying 5, yes, minus I all square. So that means we are correct. So it's simply 5 plus I square. Yes. Alright. So for here, the same thing, 5 minus 7i is simply, the conjugate is simply equals to 5 plus 7i. The same thing here, 3 minus I all square. Alright. So there you have it. Now they're also asking us, they said determine all complex numbers z that satisfy the equation. Determine all complex numbers z that satisfy the equation z plus 3z equals to 5 minus 6i. That satisfy the equation z plus 3z, and that is 3z conjugate, equals to 5 minus 6i. Alright, let's look at it. I said determine all complex numbers z that satisfy the equation z plus 3z. So what I will say is all complex numbers. Since they said all complex number z, I will take z to be a plus bi. And if I know that, so bringing this plus down, then the conjugate is going to simply be 3 into, this is conjugate of z, so I'll just say a minus bi. So is equals to 5 minus 6i. Remember, this is the question. Alright, so there you have it. So what you now do is to simplify, so that we do 3 into a minus 3abi equals to 5 minus 6i. Then we now have a plus bi plus. So what we can do is to collect like terms, so that we say a plus 3a. Then all the ones that have I, so plus, let's say we put this now. Let's say we bring out our, yes, our I. Okay, yes, let's say we bring out, yes, let's say we bring, this is 3a bi. This is bi. So let's simplify. So this becomes I, or is it b? So I will now have b into, yes, I, then so this becomes, if we do this, this becomes, remember I collected this and this together, so I want to collect b. Let me just write it out first. Let's put them together first. So I collect bi minus 3a bi is equals to 5 minus 6i. So simplifying this to like factoring out, I have b, bring b out. I have 3a, then I have I, this into this bi, this into this, sorry, 3ab, this into this, yes. So yes, that's it. Yes, sorry. This is 3 times a, 3a, 3 times bi, 3bi, not a. Where did you get a from? God forbid. So this is supposed to be b. So yes. So by the time you do it, you now see that we have a plus 3a plus b minus 3b all into I is equals to 5 minus 6i. Okay, so if we choose to now collect to equal it now, you now see that we now have the real parts. So we now have 4a plus b minus 3b is going to be minus 2bi equals to 5 minus 6i. So this is the sentence saying 4a is equals to 5, comparing. So then minus 2bi is equals to minus 6i. This will cancel this. So you see that a is equals to here 5 over 4. While even I can cancel I. While b is equals to 6 over 2. So b is equals to 3. While a is equals to 5 over 4. So there you have it. That's my answer. So if you want to put it now in the form of complex number, you now have that this is the sentence saying that is in the form a plus bi. This will now give you 5 over 4 plus 3i. So that's your final answer. Remember how we did it? This place wanted to confuse us, but notice that it's 3 into a, 3a, 3 into bi, 3bi. So by the time you do it, you now have to factor out. So thank you. In our next class, I'm going to be continuing from here. So this is the one we solved now. They say find all complex numbers of the form z equals to e plus bi, z equals to e plus bi, where a and b are real numbers such that z times z conjugate, z times z conjugate is equals to 25, and a plus b is equals to 7. All right, let's move and solve the question. So this is what they give us. So if this is a plus bi, it simply means that the conjugate of z The conjugate of z will be equals to z conjugate will be equals to a minus bi. Putting it in this form, I will now have a plus bi times a minus bi is equals to 25. A times a square. A times minus bi will be minus abi. Then b times a will be plus abi. A plus bi times minus bi will become minus b square I square is equals to 25. This will cancel this. A square minus b square. I square is minus 1. That is, I itself is equals to root minus 1. So I square will be this, cancel this. So minus 1. So minus 1 times this becomes plus b square. A square is equals to 25. So down here, if you remember, a plus b is equals to 7, which means that a is equals to 7 minus b. Is equals to 7 minus b. So let me replace this a with 7 minus b. So I now have so I'm going to have 7 minus b all square plus b square equals to 25. Yes. So that I now have 7 minus b, 7 plus b square is equals to 25. 7 times 7, 49. 10 times b plus 7b minus 7b minus b square plus b square equals to 25. This will take care of this, so that I now have 49 minus b square. Yes. This minus minus b times b is b square now. Yes. Then I have b square. So this is supposed to minus b square plus b square. This will be 0, so equals to 25. Oh. Okay, what if I did b here? That is a plus b. What if I did b equals to 7 minus a? So for b equals to 7 minus a, let's say as I have a square, from here where I have a square plus b, that is from here. I have a square plus b square equals to 25. Let me choose to replace b. So I have a square plus 7 minus a all square equals to 25. So if you do it, I will now have 49. I'll still have 7 times 7. I have 49 minus a square equals to 25 plus a square. So it's looking, what is happening? Okay, let me FOIL it this way. 7 minus a. This will be 7 times 7, 49. 7 times minus a minus 7a. Minus 8 times 7 minus 7a plus a square is going to give me minus 14a plus a square 49. Okay, let's do it this way. I was solving it initially as difference of two squares. So now this is going to be, if I carry this into this, remember that this is this part for b. So if I choose to neglect this, so replacing this now, I'll have a square plus everything here, 49 minus 14a plus a square is equals to 25. So let's now do something. 14a, then 49. So let's do this. A square plus A square is going to be 2A square. 2A square, yes. 2A square, then minus 14A. 14A, then this is plus 49. I'm going to carry this one crossing over minus 25 equals to 0. This is now looking like a quadratic equation. So this becomes 2A square. So this is 49, remember, minus 14A. 49 minus 25 is 24, so plus 24 is equals to 0. So this is a quadratic equation. So I think the problem we wanted to have is foiling this as difference of two squares. So it's best foiled as, or should I say opened as minus that it is, so that we've got a quadratic equation. So now let's solve the quadratic equation. We can use difference of two squares to say 2A square over 2 minus 14A over 2 plus 24 over 2 equals to 0 over 2. So that this cancels this. So we have A square minus 14, sorry, this here 1, here 7. So minus 7A plus 12 equals to 0. So difference of two square, let's say take half of the coefficient of x, which is this one. So this is going to be 7 divided by 2. So 7 times half is going to be 7 over 2. 7 over 2. Then add it to both sides. So we now have A square plus 7. So I'll cross over. So the constant. So 7A plus 7 over 2. Yes, this is minus, sorry. Should be minus, yes. Minus, and this is going to be minus, because that's it. So half of it. So equals to this one crossing over becomes, yes, initially it was 49 minus 25, yes. So this crossing over becomes minus 12, then add to both sides. So add minus 7 over 2 to it. So when I do this, taking the LCM, I'll have A square, and you add the square of the coefficient to both sides. So square is what you add. So 7, so this becomes 7 plus A plus 7 minus 7, or you see A, yes, or you see A minus 7 over 2 all squared is equals to square 7. 7 square is 49, so minus 12. 7 square is plus 49, then all over 4. So over 1. So this 4 here. 1. So 4 times 12 is 48 plus 49. This is minus 48 plus 49 all over 4 equals to everything here. So this is going to be 49. So this is going to be 1 over 4 equals to the left hand side. Go and learn how to do quadratic equation polynomials is on my channel. So this is going to be A plus 7 over 2. Then the equality sign moving over, crossing over, becomes equals to plus or minus square root of 1 over 4, which is going to be the sentence saying plus or minus 1 over 2. Then I have A plus 7 over 2. When this one cross over, this becomes the sentence saying A equals to 7 over 2 plus or minus 1 over 2. So this is going to be the sentence saying 7 over 2 plus 1 over 2. So 7 plus 1 is equals to 8 over 2. 2 here 1, 2 here 4. So 4 over 1 is 4. So A is equals to 4, or 7 minus 1 all over 2, which is the sentence saying 6 over 2. So a is equals to 3, or that means a is equals to 4 or 3. That is what you must know. Now remember that if a is equals to 4 or 3, there's a place where we did initially. If you remember, right here we said a equals to 7 minus b, and we said b equals to 7 minus a. You need to be following this video gradually. So let's now do when, that is, remember, b is equals to 7 minus a. Is equals to 7 minus a. So when a equals to 4, b is equals to 7 minus 4 equals to 3. And when a is equals to 3, b is equals to 7 minus 3, b is equals to 4. So that means that if I'm doing it that way, this is now going to be such that we now have our z to be equals to 4 plus 3i, or 3 plus 4i. That's what it means. That's what it means. So that is a plus bi, or a plus bi. You need to understand it by taking your time to go through it. Thank you. All right. There's a find all complex numbers z such that 4 plus 2iz. Notice that this is setting as saying z multiplied by this, then plus 8 minus 2i, conjugate of z. Always think of this as a plus bi to multiply this. Then this one now will be the conjugate a minus bi to multiply this, and is equals to this. So let's write out everything we're given. We're given 4 So this is what we have. So this is what we have. So this is something I say 4 plus 2i into a plus bi, then plus 8 minus 2i into a minus bi. That is what this one represents. This is what this one is equals to minus 2 plus 10i. So what you just need to do is to multiply through. So multiplying through, we now have here you collect like terms. So remember that this is I square, and I square is minus 1. This is I square. I square is minus 1. And this is going to be 4a. Collect all the row parts together. A. And this is going to be, if you multiply this becomes minus 2b. No longer, because minus times plus minus 2b, no longer carrying I. Then plus, if you do the same thing here, you have minus 2b. But notice something. Let's say, okay, yes. So alright, so 8a plus 4a is going to be 12a minus 2b minus 2b is going to be minus 4b plus 4b minus 8b is going to be minus 4b. 2a minus 2a, 0. Yes. Yes, it's going to be nothing. So you can very well see that we are now left with 12a minus 4b minus 4bi plus 0i is equals to minus 2 plus 10i. Alright, so at this junction we can compare, or we can choose to do this. 12a minus 4b minus 4bi plus 0i plus 2 minus 10i is equals to 0. So let's add up. So you now see that, yes, but okay, everything is going A or B. So if you add up, I think we are, yes, this is B. Okay, I think this is going to do it. We are here. So we can stop at this. This is it. Alright, let's go to the next question. So that does it for conjugate of complex number. So let's go to the next one. They said prove z is equals to z conjugate. So if z, I should prove z is equals to z conjugate. For example, if I have a plus 0i, is equals to the same thing as saying a minus 0i, and this will give me a. This is also going to give me a. Proved. So then the next one, they said if z is equals to 6, prove z equals to 6 is z conjugate equals to 6. That is, if for example z is equals to 6 plus 0i, z conjugate becomes 6 minus 0i, and whichever way you do it, they are equal. So this is all this is equals to 6, equals to 6. Proved. Alright, the next one, they said if we have z equals to 2i, find z complement. So if I have z equals to 2i, find z complement will become 0 plus 2i. So this is going to be the same thing as saying equals to 2i. 0 plus 2. So z is equal to z complement. Alright, so let's move to division of polynomials. So for division of polynomials, the basic principle is simply to be checking for conjugates. So you're checking for conjugates, or you say rationalization, using the principle of rationalization. So if I have example, they said evaluate a plus bi divided by c plus di. The principle is to rationalize the way you do your sort. So c minus di all over c minus di. That's the principle I will use. So by the time you do it through, you now have that this is going to be a into c minus di, and then plus bi into c minus di all over c times c, yes, c square, see me? Yes, then d times di once it's the same thing, just do it all once. So this is going to be minus d square I square, and I square is minus 1. So minus 1 times this becomes c square plus d square. Very simple. So if you now multiply this one gives you AC minus DAI or ADI plus BCI minus BDI square. This is going to give you AC minus ADI plus BCI I square is minus 1. So minus times this becomes plus BD all over C square plus D square. Alright, so they gave us another one. They say we should evaluate 3 plus 2i all over 2 plus 5i. Remember I told you the concept is rationalize. Evaluate this, that is 2. Evaluate this, I simply say times. What is the conjugate of this? Is the same thing as saying 2 minus 5i. Conjugate in this case is simply see the sign, change it. Plus 25. So this is going to be the same as saying 3 times 2, 6. 3 times 5 minus 15i plus 2i times 2 is 4i. 2i times 5 is going to be minus 10i square all over 4 plus 25. So this is going to be the same thing as saying minus I plus 4i is going to give me 11i. So 6 minus 11i minus 10i square all over 4 plus 25 is 29 over 29 all over 29. So what we have here is looking like a quadratic equation. That is minus 10 11i minus 6. So this is going to be the same thing as saying minus 10 square minus 11i minus 6 all over 29. I can choose to solve the quadratic equation. Yes, look at this is I square. Yes, I square. But okay, before I think of I square, let's check something. Before I think of quadratic equation, I square is equals to something which is minus 1. Shebi? Minus 1. So minus 1 times minus is going to be just plus 10. This is just plus 10. So 10, yes. So 10 minus 6 is just 4. So it's, instead of quadratic equation, it's supposed to be 4 minus 11i all over 29. And this is the same thing as saying in a plus bi form. This is the same thing as saying 4 over 29 plus 11i all over 29, or 11 over 29i. So there you have it. So I'll solve this last one, this one, then you solve the rest. So I have the 1 over 2 minus I plus 2 minus I. So this is going to be first of all 1 over 2 minus I times 2 plus I over 2 plus I. So this is going to be the sentence as anything times 1 is just 2 plus I all over 2 yes, minus I square, which is the sentence as saying 2 plus I all over I square is minus 1, so just 2 minus 1. So which is the sentence as saying 2 plus I all over 3. Yes, so over 3. So plus 2 minus I. So that is what we have all over this. So the LCM is 3 here. So just 2 plus I, then plus 3 into 2 minus I. So 3 times this 6, 3 times this minus 3I plus I plus 2 all over 3. So this is going to be the sentence as saying 6 plus 2 is 8 minus 3I plus this minus 2I all over 3. So this is the sentence as saying 8 over 3 plus 2 over 3I. Yes, that's my final answer.